Chapter 8 review. I have about 16 problems here. I'm going to try to go through them quickly, so you might want to pause, try them on your own, and see what I did. See if you agree. Okay, first one is sort of a messy log within a log. So what I would suggest that you do in here would be to say, I'm just going to leave this guy on the outside and figure out what this is. Remember, a logarithm is an exponent, so the question really is, what do I put above a 4 to get a 64? And that would be a 3. And if you recall, anytime the anti-log and the base are the same, you get a 1. You could do this on your calc. And don't forget, this really is the same as this, if you want to actually use your calculator on that one. Okay, number 2, write the equivalent form. So basically, this is one of those problems where I need to break this thing all apart. So when I see division, if I want to write that into two logarithms, I'm going to use subtraction, and since I know where I'm headed, I'm going to rewrite this radical z as z to the half power. And now when I see the multiplication here, I'm going to break that up as addition, and I'm going to go ahead and I'm going to bring that power down in front of the z here, and then grand finale, I'm going to bring my exponents in front of these. This is basically showing that you understand the laws of logarithms. Number 3, these are problems that we've been working on recently. Basically, if I can just get log of stuff equal to log of stuff, then all is well. And using my logarithm rules, laws, I can rewrite that as x squared. That means 16 is equal to x squared. I'm going to square root both sides. Now in reality, when we take the square root of 16, it's plus or minus 4, but in logarithms, it's only going to be 4. Because if you recall, the domain of logarithms is x is greater than 0. And you might want to review what the range is also while you're thinking about that. Okay, so next one, this kind of looks similar to what we've been doing basically in the last section, although the one thing you'll notice over here is there is no log. But I'm going to go ahead and start by getting these guys together into one logarithm. So I get this, and put a little bracket around here, is equal to 5. So the fact that I don't have a logarithm over here doesn't allow me to just like set these guys equal. So I'm going to do something different here, and I'm going to remember that a logarithm is an exponent and this is my base. So that must mean then that x minus 3 times x plus 1 is equal to, I'm just going back into exponential form, 2 to the 5th power, which is actually the same as 32. And then I can go ahead and get the job done here. So I get x squared minus 2x minus 3 minus 32 is equal to 0. So that would be x squared minus 2x minus 35 equals 0. I can do a little factoring here. X minus 7, x plus 5 equals 0. And I get x equals 7, x equals negative 5, but this gets rejected because of the domain. So in this case, my answer is 7. Okay, right. 2 log base 5m plus log base 5n as one logarithm. So this is just putting these kind of going the other direction. So I'll baby step my way into it. I'm going to keep my little log base 5 because that's what I was told the situation is in this case. And now to join these two guys up, when I see that adding, that turns into multiplication. And you do want to be careful because if the problem happens to come with a different base, you really do want to show that base. So I'm going to be careful with that. Okay, number 6. How do I go from logarithmic form to exponential form? Well, for me, what I do is I basically realize that I have 3 positions to fill. And I say to myself, a logarithm is an exponent. A logarithm is an exponent, so that b is going here. I think about running around the bases, and I know that has to be my base, and then this thing, which is known as the anti-log, has got to go in that position right there. That would be the end of that. Number 7, now I want to go the other direction. So how do I write y equals a dx in logarithmic form? I'm going to be the same broken record. I'm going to say to myself, a logarithm is an exponent. An exponent. So right here goes my x. This is my base. I always have a base underneath my exponent, so my base is going here, and then by process of elimination, my y is going in that position right there. That's it. Moving right along. Number 8, evaluate. We've already seen this in a previous problem. But if you recall, remember, a logarithm is an exponent. So really the question is, what do I put above that 4 to get to that 64? It's kind of a nice 4 cubed, gives me 64. But don't forget, your trusty calculator would be happy to help you by doing that. Okay, find x. So once again, I'm going to use my relationship to exponential form, and I'm just going to say this is my base. A logarithm is an exponent. This is my exponent, so that must be what x is equal to. Now you could just throw that in your calc, but just for kicks to review. Power root. Really what the easiest way I think is to think of this is it's got to be the square root of 9 to the third power. So square root of 9 is 3, and 3 cubed is 27. Okay, zipping right along here. Number 10. Same idea, just different thing we're looking for. So in this case, I'm looking for the base. A logarithm is an exponent. So this is my base, this is my exponent. So x to the half is 9. And if you remember back in the last chapter, if we want to get this guy to become just an x, I'm going to square it, and I'm going to do the same exact thing over here. So then x is equal to 81. Easy, right? Okay, number 11. I am not going to actually do this. I just want to remind you, you should be able to do this. So if you're asked to graph y equals x to the 6th, I'd hope you'd put it into your calculator. Helpful hints that make it really nice for grading is when students put nice little tables on their paper. So I can see the points that you're trying to get onto your paper for your graph. It's always a good idea to graph it as much as you can on the grid that you're given. Okay, so what is the inverse? So if you recall, finding the inverse then, this is where we found this problem. Well, we're going to switch these positions here. Actually, I'm not going to do that in this case because I'm going to do something different. Instead, I just want to talk about, you know what is weird here? I have put the wrong thing on my board. That's what the problem is. I want this to be 6 to the x. That's why I'm having this moment, and I am going to just go with it. Okay, so y equals 6 to the x. So in the exponential form, the x is going to be as the exponent. Same deal, though. I still would want to see some a table with your points. Okay, so now this is why I just came upon my trouble, because as I said actually recently in class, the way we first sort of explored the problem is that if I now want to solve for y after switching my x and y, that's where I have an issue, because I can't solve for y. So that's why we know then that the inverse of this is a logarithm. The inverse of an exponential function is a logarithm. And in this case, since the exponential function has a base 6, this is going to be 6 also. Remember, if you want to graph that on your calc, you type in log x divided by log 6, and that will actually graph that for you. Okay, number 12. This would come in the form of a word problem. I just tried to simplify it here. So, and do not be afraid. Sometimes different variables are used. So this is a kind of a banking type problem. So if you are told B is your balance, is equal to P, what's your initial, usually often called principal, times e to the ry, and you're told that P is 1200, R is 8%, and then the question is how many years to 3200? Fill in the blanks. So we want to know, when is your balance going to be 3200? If you started with 1200, and we know we have e here and our rate 8%, remember rates always have to go in as decimals, and then y in this case is years. We've seen t a lot. So what we're going to do is divide by 1200. You always want to get this thing alone. So when we have 3200 and we divide it by 1200, we get, I'm just going to write it as a simplified fraction here to make life a little easier, 8/3 is equal to e to the 0.08y. Now, you do not have to use ln here, but you got to train yourself to free exponents by taking the log of both sides. There is a great benefit to using ln though. So The ln of 8/3 then is equal to free 0.08 y ln e. What is the benefit? The ln of e is 1 because the base of the natural log function is e, and e, when we have an e and an e here, that means it's going to be 1. So now what I do is I just divide by 0.08, and in the end you would find y to be equal to, if they asked you to say round to tenths, it would be 12.3. You can check me on that one. Okay, another problem, just want to make a different point here. This is an equation that talks about millions of snowboarders in the world. Y equals 0.5 times 1.21 to the x, and x represents the year since 1988. So what year will there be 10 million snowboarders? So what are we going to do in this case? We're going to put a 10 in here. It is 0.5 times 1.21 to the x power. Once again, you always want to get the base that has the unknown in the exponent by itself. So I'm going to divide by 0.5. So 10 divided by 0.5 then is 20. So now I have 20 equals 1.21 to the x. Now, the point I want to make here is if you want, you can take the ln on both sides, but it's not necessary. I mean, there's really not a benefit because there's not an e here. So just for kicks, I'll do the log. And remember, just good old log has a base of 10. So now I have log 20 is equal to x log 1.21. This is what makes logarithms so awesome. So now all I got to do is divide by log 1.21 on both sides. And hopefully the number something like 15.7 comes out. And if I take 1988 and I add 15.7, I get 2003.7. So this would actually happen in 2004 since I'm adding from 1988. Okay, a couple more problems in this quick review. How in heaven's name do I solve for x here? Once again, it's like training. You say, oh my goodness, the thing I'm looking for is an exponent. How do I free exponents? I take the log of both sides. And when I see that e, it makes me want to do ln. So ln of e to the negative x is equal to the ln of 1 over 100. So now what happens is I get negative x ln e is equal to the ln of 1 over 100. And I personally oftentimes kind of go all through the whole thing, get it all set up, and then put it into my calc rather than take in a whole bunch of decimals with me. So lucky thing, ln of e is 1, so this is good news. And so really all I need to do here is divide both sides by a negative 1, because then I will get an x. And when you do that, you get an answer of 4.61 if you were to round to hundredths. Okay, a couple more problems. Solve for x. 4 to the x is equal to 20. Now, in the past, back in the last chapter, we might have tried to find a common base here, but notice there really isn't a common base. Don't let your brain trick you. There is not a common base. So really the easiest thing to do in this case is just to go for it and take the log of both sides. And there's not really any reason for me to do the ln, so I'll just do regular log. That allows me to free that x from being an exponent. And in the end, I just divide both sides by the log of 4, and I am done. Let's face it, logarithms are awesome. So let's say you had a round to hundredths, you would get 2.16. Okay, grand finale. I do believe this would be the last one. If log x is a, log y is b, log z is c, give log of yuckiness in terms of a, b, and c. This is the type of problem used to make you show that you understand how to deal with breaking out your logarithm. So I'm just going to baby step my way through it. I'm going to say, well, I see a quotient, so I'm going to take the logarithm of my numerator minus the logarithm of my denominator, and I see the radical z. I'm going to rewrite that as e to the half. And I'm going to just break this baby apart. So log x squared plus log y minus 1/2 log z. And one more move here. 2 log x plus log y minus 1/2 log z. And then I'm in the position where I can say, well, they told me log x is something or other. So I'm going to come right on back up here and say, oh, log x is going to be called a here. So in place of that log x, I'm going to put in an a. Then I have this log y, and I'm going to come back up here. I'm going to say, oh, they told me log y is b. So I'm going to put a b. And then I have a minus 1/2 log z. Oh, I think they told me log z is something too, and wouldn't you know, but log z is c. So it's really just break the thing apart till you get so that you can sub in what you've been given for the different logarithms. That is it. Make sure you can graph. You want to probably review domains and ranges of exponential functions and logarithmic functions. That's all I got.